Hello students, welcome again to my YouTube channel Learning Mathematics. Today we are going to prove Möbius inversion formula and converse of Möbius inversion formula. What is Möbius inversion formula? It says if Gn is summation d divides n fd for every positive integer n, then f of n is equal to summation d divides n mu d gn by d. It is a relation between two functions f and g. If g can be written as in the form of f, then f can also be written in the form of g. And its converse formula, it is exactly the converse. If fn is equal to summation d divides n mu d gn by d, then gn can be written as summation d divides n f of d. The same functions are there. It is the relation between g and f. First we prove Möbius inversion formula. Here we are given g of n. We find g n by d. So g n by d is equal to summation. We are to replace n by n upon d. So that means divisor of n by d, and we can write c in the place of d. C divides n by d, f of c. So we are to take this term summation d divides n mu d g n by d. What is this? This is summation d divides n mu d, and g n by d is summation c divides n upon d f of c. We are having two summations. We can take them together. Summation d divides n, summation c divides n upon d mu d into f of c. We are given these two conditions. D is a divisor of n and c divides n by d. That means n by d can be written as multiple of c. That means n is equal to c k d. So n is also a multiple of d. That d divides n we are given. C also divides n. C is also n is also a multiple of c. So we can write from here c divides n. And if c divides n, we divide the equation by c. N by c is equal to k into d. That means n by c is a multiple of d. That means d divides n by c. So we replace this summation by summation c divides n and summation d divides n by c. So this is summation c divides n, summation d divides n upon c mu d f of c. Now we break this summation into two parts. C is a divisor of n. We take it as c less than n because the divisors of n can be less than n and can also be equal to n. So summation c divides n, c is equal to n. Summation d divides n by c mu d f of c. So what is this value? This is summation c divides n, c is less than n, f of c, summation d divides n by c mu d, plus since c is equal to n, so n divides n, there is only one term, so c can be replaced by n. F of c can be written as f of n. And what about this? D divides n by c, and c is equal to n, n by n. D divides n by n means 1. D divides 1. And if d divides 1, that means d divides 1, that means d is equal to 1. So we are to take d is equal to 1. So mu d comes out to be mu of 1. The value of mu 1 is 1. So it is f of n. So it is equal to f of n plus summation c divides n, c less than n, f of c into this term. What is the value? We are having here c is less than n. If c is less than n, then n by c is greater than 1 from this inequality. And we know by F Merton lemma, summation d divides n mu d is equal to 1 if n is equal to 1, 0 if n is greater than 1. This is our F Merton lemma, and I have already told you that will be used in Möbius inversion formula. So we are having here the number n by c, and n by c is greater than 1. When n is greater than 1, the summation of mu d, summation of divisors of n mu d is equal to 0. So here again mu d, summation mu d, d is the divisor of n by c and n by c is greater than 1, it comes out to be 0. So this value is 0. So 0 into f of c, all the terms are 0, the value is f of n. So f of n is summation d divides n mu d g n by d. It is to be proved f of n is summation d divides n mu d g n by d. The right hand side we have started with and we got the answer as the left hand side. Same is for the converse of Möbius inversion formula. We are given here f of n, we find out f of d. So now f of d is equal to, we are to replace n by d here, so we replace d by c. So we are to place d is equal to c and n is equal to d. So summation d divides n, that means c divides d, mu of d, that means equal to c, g, n upon d. N upon d, that means d upon c. We are to take the term summation d divides n f of d. So summation d divides n f of d is equal to summation d divides n summation c divides d mu c g d upon c. Here we take one more step. We replace d by k into c. We put d is equal to kc. So that means summation k into c divides n summation c divides d, because c divides d, therefore d can be written as multiple of c, therefore we have written d is equal to k into c. C divides d, that means c divides k into c, mu c g d yani kc by c. C divides kc, that means c can be cancelled out from both sides, 1 divides k. If 1 divides k, that means there is only one possibility, it is equal to 1. So this summation can be excluded. Summation k into c divides n mu c g, c and c are cancelled out, it is g of k. Now kc divides n. This summation is to be broken into two parts. Kc divides n, n is the multiple of kc into say b. So since kc divides n, n can be written as kc into b. Therefore n is a multiple of k, k into cb. So therefore k divides n. Also if k divides n, then n by k can be written as c into b. Therefore c divides n by k. So we can convert this summation into these two summations, summation k divides n and c divides n upon k. So therefore we write summation k divides n summation c divides n upon k mu c g k. As we have written in the previous, c less than n and c equal to n for the divisor of n. Here divisor of n is k. We break it in two parts, k less than n and plus summation k divides n, k is equal to n, summation c divides n by k mu c g k. Now we are to find the value. Summation k divides n, k less than n, g of k, because this summation is independent of c, so summation and this term is independent of c, therefore it can be taken out of the summation of c. Summation c divides n upon k mu c plus. Now k is equal to n, so this summation can be replaced by k is equal to n, so this value is g of n. Now k is equal to n by n is 1, c divides 1, divisor of 1 is only 1. Here we have done the same thing, divisor of 1, d divides 1, then d is equal to 1. Here it is c divides 1, therefore c is equal to 1, it is mu of 1. And mu of 1 is equal to 1 by the definition of mu function, this value is g of n is equal to g of n. Now the first term, summation k divides n, k less than n, g of k. What is this value? N by k. Since k is less than n, Therefore, n upon k is greater than 1. We divide both sides by k. And if n by k is greater than 1, so this summation, as from here, summations, the d divides n by c mu d, it is 0. And here n by c was greater than 1. Here c divides n by k and n by k is greater than 1. This summation by f Merton lemma, it is 0. So this term is 0. So right hand side is equal to g of n. So g of n is summation d divides n f of d. This was to be proved. Thank you.